Hi there, this is Imaneo. Welcome to my channel. So in this series we are trying to build a game using Flutter and Flame game engine, and the game is called Flappy Dash. So in this video we are going to implement the state management for the game. And this is the 7th episode, I think. If you haven't watched the previous videos, I highly suggest you to watch them because it's a series and you need to watch all the videos. And yeah, so let's see what do we have here. I'm gonna show you the latest state of the game. It is here, and as you see we have the score on the top center of the page, so it is getting increased when you pass a pipe. And also if you take a look at the logs, you see that when you hit the pipe, for example here, you see that we write game over here. So nothing happens inside the game, but we just print the game over statement here. And yeah, so first of all, let's take a look at the block library that we are going to use. So it's a library for state management, and I mean there are other solutions for state management, but I really like block, also qubits, which are inside the block library. And I'm gonna use this solution for the state management, but you are free to choose any other kind of state management that you like. And yeah, so the concept is like this. I have the page open here. So you have your UI, this is the page or the game that you have your qubits, and you have your data, for example data sources, repositories, anything that you have. And the point is that the interaction happens on the UI and it is communicated to the qubit and blocks using some functions or events if you use block. And also it has some states that are coming from the qubit to the UI. Yeah, for example, when you click on a login button, it's gonna be a request and a response from your backend, and then as a result your UI can receive some states to update the visualization or visual part of the app. And yeah, so this is the idea behind the qubit. So it is a unidirectional flow, so the events or functions are going to the qubits and the states are coming back from the qubit to the UI. And yeah, so fortunately we have Flame block library, which is a wrapper around a block library that we have, and it allows you to integrate the block into the component tree that you have. So as you remember, in Flame we have a component tree, and for example, if you have a player, you can just add the block listenable, and then you will have access to the new states that are coming from the block or qubit. And yeah, so to do that, I'm gonna add this dependency to the project. So we can use Flutter pop add flame block, and it's going to find the latest version, and it just adds the dependency in the pubspec.yaml file that we have. And now we can create a directory here called block, and inside that I'm gonna create a directory called game, because we are gonna have game qubit and game state inside that. And as you see, I have two options here when I hover my mouse on the new menu. So here we have block class and qubit class. So it is coming from a plugin that I just installed in my IntelliJ. I'm gonna show you. If you open the settings and if you click on plugins, in the marketplace you can search for block. And yes, this is the library that or plugin that I'm using for my IntelliJ. It allows you to create the qubit and block boilerplate codes easily. So I'm gonna create a new qubit class. So there's a difference between qubit and block. In my opinion, block is more complicated, but qubit is simpler, and I think it is perfect for our game. So I'm gonna use qubit here. But if you want to know what are the differences in details, you can write me down in the comments. Then I will record a new video maybe to compare block and qubit. But it is the simpler one, so you can just have some functions and you can just call them from the UI. So I'm gonna use this one and I'm gonna name it game, and it's gonna be, you can define a style here. We have basic, equatable, and freeze. So I'm gonna use equatable, and when you click OK, it creates the game cubit and game state. As you see, it extends the equatable. So to do that, we need to add the equatable package. So if you search, you see that we have a package called equatable. So it is just a simple package that overrides the equals and hash code and two string functions for you. So yeah, the use case is so simple. You can just extend it, or you can just add it as a mixin. Yes, with equatable mixin, and then you need to provide the list of properties that you have or your data class has. And yeah, so I'm gonna import the package here. We can say flutter pub add equatable. Yeah, so if you take a look at the postspec.yaml file, you see that it just added the equatable package, and now it is resolved here. So you can just take a look at it. Yeah, it overrides the equals and hash code and two string for you. Yes, so here I'm gonna remove the sealed keyword here because I'm just using a simple state. I'm not going to use sealed classes. And also I would like to use equatable mixin. I feel better with that, so I'm gonna use equatable mixin. And we just need to pass the parameters or properties that we have to this list. And also in the game cubit, I'm gonna use game state. Okay, so now let's define our state. I'm gonna use an integer here for our score, or we can say current score. And we are gonna have an enum here, which is the playing state. And we have none, we have playing, we have maybe paused, and also game over. So this way we can keep track of the current state of the game. For example, when you hit a pipe, we can change the state to game over, and then we can pause everything and show the overlay to show the restart button and your best score maybe. Yeah, so here I'm gonna create a final playing state of current playing state, and I'm gonna add these two to the properties that we have here. And also in the constructor, I'm gonna initialize them with a default value. So score is gonna be 0 and playing state is gonna be none. Playing state dot none. So we need to add this keyword to initialize these two properties. And also we need to create a copy with function to be able to create a new state but changing some properties. We can have copy with. So here we are gonna have some optional properties, and we are going to return a new state, and the properties are going to be these two, and these are going to be optional. And we can say current score is current score, otherwise this dot current score, and also current playing state is gonna be current playing state, otherwise this dot current playing state. So it is a simple copy with function. If you pass something here, it just replaces and returns you a new state. And also if you pass a playing state, it just overrides the playing state and returns back the new state. And in the cubit, we can create some functions. For example, we can create a method called start playing. So suppose that when you run the app, you see the bird, but the game is not started yet. And when you tap on the screen for the first time, we call this method that play the game. So we can call this method to just change the playing state from none to playing. So this way we can move the pipes and allow the player to jump and so on and so forth. So here I'm gonna just emit a new state. We can say current state.copyWith, and playing state is gonna be playing. And also we need to reset the current score to 0, Yes, I think this function is good. We can just call it to change the playing state from none to playing. Oh, by the way, let's define the type here. It can be a void. And after that, we can have increase the score. For example, we call this method when the player passes the pipes. So here we can just emit a new state with the change that we just increase the score. So here we can say state.current score plus 1. Also, we can have a method, for example, when you hit a pipe, it is called game over. And here we can just emit a new state, and we can just change the current playing state to game over. And yeah, so I think this is the business logic that we have for now. So we are good to go. And now let's add the game cubit to the widget tree. So as you know, we have some block providers that we need to add it to the root of the widget tree to allow the widgets to access the cubit that we create there. So I'm gonna open the main.dart file, and here I'm gonna wrap the material app with a block provider. Yeah, here we have a flame block provider, but it is for flame. Here we just need to add the normal block provider. I think we need to add the Flutter block package. Yes, let's take a look. Yeah, as you see here, it allows you to define the block provider. So I'm gonna use it here, and we can say Flutter pop add Flutter block. Yeah, so now we are able to use block provider here in the root of our widget tree, and it needs a create callback. So here we can create our cubit. It is game cubit. So we don't have any dependency to inject. We just need to call the normal constructor. And now we are ready to use the game cubit in the widget tree that we have. For example, in the Flappy Dash game, we can have it in the constructor. We can have a game cubit, and we can request it in the constructor. Yeah, and when we create the Flappy Dash game, we can pass the cubit here, and to get the reference to the cubit that we defined in the root of widget tree, we can have block provider.of context, and here we are gonna add the game cubit generic type. So this way we will have access to the game cubit. Yeah, by the way, I can have a reference of this one here. We can define a late variable of game cubit, and I'm gonna initialize it here, and then we can pass it to the Flappy Dash game that we have. But the point is that it is available in the widget tree that we have. But as you remember, Flame uses component tree. So to be able to use game cubit in the components, we need to add it at the Flame block provider in the root of component tree that we have. Yeah, so as you see in the Flappy dashboard, we have some components that we are adding, but now I'm gonna move all of them to a new component that is the root component, and I'm gonna wrap it with the Flame block provider to make sure that the cubit or the block is accessible to all the components that we have. So to do that, I'm gonna define a new class here. It's gonna be root component. I'm gonna write Flappy Dash here, so it is Flappy Dash root component, which extends a normal component. It is not a position component because it is just a concept, so it doesn't have any position or something like that. And yeah, I'm gonna move all of them here. We are gonna have the dash, we are gonna have last pipe and pipe distance and everything. So let me copy paste these codes. Yes, and it's gonna have this mixin. Also we need to move the tab callback to here. Yeah, I think we are good to go. Oh, by the way, here we just have the keyboard events and we just pass it to the word. What can we do? Because this callback should be handled inside the Flame game. And for now, I'm just going to create another proxy here. So just like what we have here, I'm gonna create a function here in the word. I'm gonna call the untap down of the root component that we have. So in the onload, we are gonna have a void here. And yeah, so here we can just add this component like this, and we can have a reference of root component, and we can just proxy the function to the root component. Now we can wrap it with the Flame block provider, which is a component. So it injects the game cubit that we have into the component tree that we use in the Flame. So after that, we are able to use the game cubit in the player, in the pipe, or wherever that we want in the component tree. So I'm gonna cut this code and I'm gonna say Flame block provider, and as a create, I'm just going to return the reference that we have in the game. I can say game.gameCubit, and as inside the children, I'm gonna add the root component. And yeah, so this way we are injecting the game cubit to the component tree. So this is the toppest component that we have, and after that we have the root component, and here we just add the dash, we just add the pipe pair and other things. And yeah, so we have an error here. Yeah, because we are calling the increase score from the dash. So I'm gonna just use cubit here to directly call the cubit method. And here we can have flame block reader. So we have flame block listenable and flame block reader. Listenable is for when you want to have some callbacks for the states, but using flame reader, you can just have access to the qubit that you have. And here I'm gonna say game qubit and game state. And now you will have access to the qubit or block. Yes, it is called block, and as you see, the type is game qubit, so we can just call increase score instead of this one. Also here we can just write block dot game over. So I'm gonna remove this print statement here. And oh, by the way, let's remove the logic that we have for the score here in the root component. As you remember, we have the score property here. I'm gonna remove it. And here, when we initialize the text component, we can just ignore the text, so we don't show anything when you open the game. And yeah, we can remove this function because we don't need it anymore. And in the update method, when we update the text, we can just use block that we have, but we need to add the flame block reader that we have, game qubit and game state. So you can just add this mixin into all the components that you have, then you will have access to the game qubit as a top level state management that you have. Here we can just change it to future. Here I'm gonna use async keyword, and we need to await for the super.unload. And here we will have access to the block, which is the game qubit again, and you can have access to the current state. And here we will have access to the current score. So it is an integer and we need to change it to a string. So I'm gonna replace this code with this one. And because the update method is gonna be called in every frame, we are gonna update the text with the current score that we have. So we don't need to listen to any state change because we are in the update method. We can just read the value and we are pretty sure that it is updated all the time. And yeah, so I think now I can run the game to see what happens. Okay, we have some errors. No flame block provider available on the component tree. Oh, I think we need to add the generic types here, maybe game cubit and game state, to see if it solves the issue or not. Yes, so as you see, we just needed to add the game cubit and game state generic types here. But the point is that the tap callback is not working anymore because we just moved it into the root component, the tap callback, and the point is that it doesn't have any position or size to allow you to tap it. So it's just a component and it doesn't know how to handle the tap callback because it doesn't have size and position. So we need to move it back to the word that we have. I'm gonna paste it here and I'm gonna proxy the event to the root component. So I'm gonna copy this logic and I'm gonna paste it here, and instead of dash.jump I can say root component on tap down, and we can just pass the event and we can create this method, and inside that we can use dash.jump. Yes, we can add it here. And now we should be able to tap, and yeah, so we have the state on the top. Yeah. Okay, so now we are showing the state correctly, and in the next step we just need to implement the game over. To implement the game over, at first we can just stop the pipes movement. So if you remember, we have pipe pair that it updates the X position per frame. So we have a speed and so on and so forth. So we can have access to the blocks here using flame block reader, and I'm gonna use game cubit and game state here. So in the unload we need to use future of void, and here I'm gonna await for the parent or super.unload, and in the update we can say if, or we can have a switch over the block.state.playing state, and let's implement all the cases. If it is none or game over or paused, I'm gonna move them here. We don't move it. Otherwise, if it is playing, we just copy paste this logic here. So this way we just move the pipes when the playing state is playing. So let's see. You go, and when you hit a pipe, yeah, so let's print the current playing state to see what is it in every frame. Yeah, so it is game over. Oh, I think we need to break the switch case. That is the issue, I think. Oh, so it is none and it doesn't move. It is okay, but for now let's just copy it to paste it here. And yeah, when you hit a pipe, game over calls, and as you see the trees on the background is moving, we also need to pause them, and also we need to prevent the user to be able to jump, and we can just stop the character movement. So we can update the dash.dart here. We can have access to the flame block reader. Yeah, we already have access, and we can just say if block.state current playing state is not playing, return. So we don't do anything if it is not playing. And also we can stop the movement. We can say if it is not playing, please return. So we don't do anything. Okay, so let's revert this code from the pipe pair. So we don't want to move it if it is in non-state. So If you play, it is like this. And now we can just have a text here to show something like click to start. Then we are able to click to start the game. And in the dash, yes, on tap down and on space down. Yeah, so here I can just have a function, for example, check to start, and I can implement it. And inside that we can say if block.state.current playing state is playing state dot none, we can just say block.start playing. Yeah, and it is just for the first time that you tap on the screen, it starts the game and the playing state switches to the playing. So after that, the pipes are gonna move on the left side of the screen. And if you click, yes, you see that the game starts and you have the score, and when you hit the pipe, it stops. But also we need to stop the background. So I'm gonna copy paste the code from our dash. Yes, here I'm gonna copy paste the code for dash parallax background. So I'm gonna copy paste the update method, and we can just have flame block reader, game cubit, and game state. Yeah, we need to call super.unload to make sure that the flame block reader loads the qubit or the block that we have here. So yeah, so we just added an if statement here, and we don't update the super, which is the parallax component, to prevent the objects from moving to the left side. So this way we prevent the parallax component from moving. But the point is that because when you start the game, it is in non-state, it doesn't get updated and it doesn't show anything. So we can just say, we can just change it to a switch statement to check if current playing state is none or playing. We can update it. But if it is paused or game over, we don't do anything. Yes, so if you run the game, oh, we need to return this if statement here. And yeah, so as you see, the background is moving, and when you tap for the first time, game starts, and when you hit a pipe, everything stops. So it is correct, and now we can have an overlay to show the game over state. Okay, so let's get back to the main page that we have. So as you remember, we have a scaffold, and also we have the game widget, which is a full screen widget that we show here. So I can just cut this piece of code, and here we can have a stack, and in the children we can have the game widget, and on top of that we can have a container, for example, with a colors.black of 45, for example. And if I hot reload, you see that we have the black overlay. Let's increase the opacity to 87 maybe, or 54. Yes, and inside that we can have a text maybe, or a column. And as children we can have a text which says game over, and yeah, it is here, but we need to wrap it with the center, and the main axis size should be minimum. So this way we have the text in the center of the screen. And also let's change the style to a text style. For example, we can change the color to colors.white, and also we can make it bold. Font weight can be font weight dot bold. Yes, and also we can increase the font size to 28 maybe, or 38. Yes. And now we can have a button here. It can be a text button, for example, or we can have an elevated button. So we can have a text of play again, and let's remove the constant keyword here, and let's just add it here and here. So if I hot reload, you see that we have a button here, which is the play again. And let me remove this log because it is annoying here. Where is that? Yes, it is here. Okay. So let's see. Yeah, we have the overlay here, but the point is that we are showing it all the time. But we can just wrap the scaffold with a block builder. So here we can define the generic type. It is game cubit. And yeah, so inside the builder, you are gonna return a new widget tree based on the state. So I'm gonna say if state.playing state is game over, we are gonna show this container. Otherwise, we don't show anything. So let's run the game. Yeah, this is the first time, and when you start the game and when you hit a pipe, you see that the game over shows and you can click play again. And now we can just add something here. We can just have access to the game cubit and say restart game. Do we have that function? No. So let's create it, restart game. So we are gonna call this function create method. Yes. And here we can just say emit a new state, change the current playing state to playing state dot playing, and reset the current score to 0. Yes, let's do a hot reload, and if we play again, oh, so we need to reset the whole game because the game instance has the pipes and also the player, and when you change the playing state to playing, it just uses the same reference, and that's the problem. So to do that, I'm gonna have a code here in the main page. So as you remember, we have a Flappy Dash game, which is an instance that we created when we have the init state in main page. And also I'm gonna change it to block consumer. So this way we are able to listen the states. And yes, so here we can check if the previous state was game over and the new state is playing or none. We can recreate the game instance. So this way we reset the whole component tree that we have in the flame. So we are going to create a new component tree. So this way we reset the whole game. So to do that, I'm gonna keep the latest state here, and we can have it as a late variable. So we can say it's gonna be a state, and we can check, or it can be null by default. We can check if state dot playing state is playing state dot none, and latest state was playing state dot game over. Oh, by the way, it should be playing state, not a game state. We can use playing state. And yeah, so this is the logic. So we check if the new state is none and the old one is game over. And also we just need to change it to none. When you restart the game, you need to go to the state that you have initially. And yes, here we just said if the current state is none and the old one is game over, it means that you restarted the game. And here we can just say create a new instance of the Flappy Dash game and also set a state to update the widget tree. And let's see. Yes, it is working, but we have a problem. When we restart the game, nothing happens, and when you click again, it works. I think I know what is happening. So we have the player here, and in the on collision we just call the game over if the player is overlapped with one of the pipes. So here we just need to say if block.state.playing_state is not playing, return. So we don't need to run this logic if the playing state is game over or something like that. So let's see. Nice. Yeah, so that was the problem because it was running. We needed to add this check here to prevent it to call the game over again. And yeah, so you see that when you hit a pipe, you see an overlay, and you need to click the play again button to restart the game, and also the score restarts. Okay, so I think we are done. So let's take a look at the game over screen. We can just add some space here. So it is in main page, and here we are gonna have a sized box, and as a height I'm gonna use 18, for example. Yes. By the way, let's copy it to create a new widget from it. So stateless game over widget. So I'm gonna paste it here, and we can say block provider.off, and here we can say game cubit dot restart game. By the way, there is a simpler method of doing this. So you can just say context.read, and inside the generic annotation you can just write the qubit name, and it is exactly this one, but it is simpler and shorter. So I'm going to use this, and here I can just add the game over widget, and it is simpler now. We can move it to a widget directory. Maybe we can create a widgets directory, or widget as a singular, and here we can have game over widget dot, and I can just put the game over widget here, and also we can import block and game qubit, and here we can import it. And yeah, so later we are gonna improve the font. Maybe we can have some blur effect here, and I think it is fine for now because we just focused on the state management and the scores. We focused on the functionality, and it is working well. And yeah, so as a recap, we just created a block here. It is not block but a qubit. It is called game qubit, and inside the state we have score and playing state, and the none is for when you just run the game. It is the none state, and when you tap it changes the playing state to playing. We don't have any pause yet. And the game over is when you hit a pipe or something like that. And yeah, for example, this is the playing state, and when you pipe it is game over state. So we show a black overlay. And yeah, so in our qubit we have some functions here. The first one is start playing. So when you tap on the screen for the first time, it just changes the playing state to playing, and it just resets the score. And when you pass a pipe, we call this method to increase the score. And when you hit a pipe or when you collide with the pipe, we just change the playing state to game over. And also when you click on the play again, we just reset the state to none, and also we reset the score. And the point is that we needed to import the qubit to the component tree of the flame because we have it in the widget tree, but also we need to inject it into the component tree that flame has. And to do that, we just added it in the Flappy Dash game. So we created a Flappy Dash root component, which is responsible to generate the pipes and add the dash and everything. And in the Word, we just added the flame block provider to inject the cubit in the root of the component tree. And as a child, we just added the root component. And for now, we can just move it to a component called Flappy Dash root component to make it simpler. So I'm just going to cut this piece of code. And let's import everything, and also here we are gonna import the Flappy Dash root component. Yeah, so now it is simpler. We need to add everything in the Git. Yeah, and yeah, so we just added it in the root of component tree that we have. Also in the main page, when we detect that the user just restarted the game, we just change the reference of the game component that we have. So it is Flappy Dash game. We just change the instance to make sure that we reset the game state. So we remove everything and we create everything again to make sure that the state is clean. Yeah, it is here. So we just said if the current playing state is none and the old one is game over, and it means that this button is clicked when user was in the game over screen. The play button is clicked, and yeah, this is the logic to create a new reference of the game. And also here we have a check to say if the playing state is game over, we can show the game over widget, which is this one. So this is an overlay. And yeah, also we had some logics in the dash and the pipes to stop the movement when, for example, in the pipe pair, we said if it is paused, game over, or none, please don't move it. If it is playing, you can move the pipes. And for example, in the background, we just say that if it is none or playing, you can move the background. Otherwise, please don't do anything. So that's why when you are in the none state, you can see that the background is moving. Yeah, by the way, we can add a text here to let the user know that they need to click here to start the game. So I'm gonna add something in the main page, and we can say if state is playing state dot none, we can just show a text, press to start. And yeah, it is on the top, but I'm gonna add it in the align, and alignment can be, let's see what is 0 and 0. Yeah, 0 and 0 means center, but let's increase it to 0.2 maybe, and let's increase the size. Color can be colors.black. Font weight can be font weight .bold. Font size can be 28, for example. Yeah, so when you are in the none state, you see this text, and when you press, it's gone and you can play the game. Yeah, I just explained everything, and I think we are done with this video. In the next episode, maybe we can improve the UI UX. Maybe we can add some animations or fonts to make it better. Or also we can add some audio and sound effects. So we will see. Don't forget to like and subscribe the channel. Also, please share it with your friends or colleagues. And stay tuned for the next video. See you next time. Bye.